Hi, everybody. Just kind of gonna go over the videos for the last module, the chi-square test. Couple of things coming up. All right. Last module, going over two-way tables and categorical variables, chi-square tests all tied into there. Um, Next week, after we're done with module 10, will be the final exam. I need to go back into the syllabus a little bit. You could check that as well, and the course schedule, but I'm pretty sure it's the final exam review sheet. Kind of working on that, putting those pieces together, and then going over the basically getting prepared to take the final exam. My goal is to try to do that all within 1 week, so that way I have enough time to grade. And also, if there's things that I need in terms of, back work or anything like that, um, I can get that to you. So, or you can get that to me if I ask for it. So kind of looking forward to where this module is going to take us. We're going to be working on the um, two-way tables. And like last week, I'm actually just going to share my Chromebook. Excuse me, that's my dog barking. No. There we go. Sorry about that. Um, just didn't want her to bark the whole time in the background. So what I'm going to be going over, all right, and the reason why I am doing this just using my Chromebook, or using Excel instead of trying to do the notes is again kind of the same reason as last week. I don't want the notes to be redundant, the same exact thing that you're getting with the video. I want the video to have a purpose. Um, and there's a lot of techniques that have to be applied in this module with Excel. Two-way tables, okay? When you're looking at a two-way table, what you're seeing is one categorical variable versus another, and kind of understanding the relationship between those two variables. And sometimes there's just not going to be a relationship between those two variables. This first video, I'm going to go over a lot of all of the prerequisite stuff that doesn't relate to the chi-square test, but still is very important when trying to better understand the relationship. And it's actually a lot of stuff that we have done before when looking at a two-way table with probability. Now, there's going to be some probability stuff that kind of creeps in, um, but I'm going to do my best to try to make sure that I veer this kind of more in the direction of understanding what a two-way table is. Okay, so again, trying to stay away from what I do with the notes so that way the video has value. I'm going to do a different example. This example is credit hours versus GPA. Okay. Um, This, the credit hours is what we would call the column variable, okay, because the categories are broken down into columns. And then the GPA would be what we call the row variable, okay, again, because the rows are the responses. And that's very important to understand the responses, okay? And I'm actually going to get rid of this here because I don't want you to have the totals yet. And when you look at the homework assignments, I actually start off with tables that look a lot more like this, um, that are missing those total columns, and there's a reason why. So if I'm just looking at this table, okay, one of the most difficult things students have when they first encounter a two-way table is just how to read it. So the way that I would read it is out of everybody in this study, and I don't know how many people are in this study yet, um, but out of everybody in this study, 283 students took 12 to 14 credit hours and received a GPA of 2 to 3. Okay. If I were to look at another cell, okay, in the two-way table, 649 students had 15 or more credits and received a GPA of 3.0 or greater. Okay. And that's kind of like, you're starting to see a little bit of a pattern here. The whole goal of this module is to really solidify what that pattern is and provide data and statistics to actually back it up. So the first thing that I'm going to get into, okay, is the totals and explaining how we find those totals. That's why I deleted it, because I want to show you how to do that. So what I do in Excel, and you don't need to do the totals in Excel, it's pretty easy to do with a calculator. I'm going to just highlight that these are the totals. Okay. And then what I'm going to do is I'm just going to add a function, and I'm going to say the sum, and I want the sum of those three. So what that means is there were 222 students, 222 students that received a GPA of 1.99 or less. Okay. Then what I would do is I would add up the next row. Okay. And this would be students that had a 2 to 3 GPA. And that's 673. Okay. And then my last row, I'm going to add them all up. And this would be 974 students who had a GPA of 3 or greater. Okay, so now I've answered how many students fall into each of the GPA row categories. Okay, now what I want to do is I want to add down the columns. So I'm going to do a column. Oh, I don't want that. Shouldn't be 0. So I'm going to do the sum of these three, and that would be 298 students who took 11 or less credits part-time. Okay, I think that's part-time. I'm not really sure anymore. Then what I would do is I would add the students in 12 to 14. 585 students took 12 to 14 credits. Okay, notice I'm not talking about the relationship anymore between the column variable and the row variable, because the only thing I'm focused on with this marginal frequency, the total, is I'm worried about just how many are in that column. And then I'll do the last one. Okay, and this last one, I'm going to do the sum of those three. Okay, and I got 986. So 986 students took 15 or more credit hours. Now, the most important cell in your marginal frequency, I cannot emphasize this enough. The most important cell is the sum of the bottom right. And you can do this one of 3 ways. You can add down the column and get 1869. Now watch what happens. If I deleted it and I added the sum of this row, 1869. Okay. Or I could just add up all the values inside the table, not the margins, and I'm going to get 1869. What that 1869 number represents is N, the sample size. Okay. And it's a really important value when we're doing a two-way table, because that sample size is going to be used to calculate a lot within our chi-square test, but also some of the very important probabilities that we're going to discuss. So the next thing that I want to do is I want to talk about the joint distribution. So the joint distribution, okay, is the percentages. So what we're going to do is we're going to look at the same exact table, all right, within the same problem that we were doing before. Okay. And if I delete this, it's probably going to delete all my numbers. So I do need to kind of go back through. Okay. Actually, I can delete them all now that I know that this is 1869. Okay. And what I want to do is I want to change every cell, the margins to, into probabilities or percentages, because what that's going to allow me to do is it's going to allow me to take those values, all right, and look at them as percentages of the entire sample. Okay. So for example, if I wanted to figure out the percentage of students that took 11 or less credit hours and received a GPA of 1.99 or less, what I would do is I would take this 146 value and I would divide it by the sum total. Okay, now I'm actually going to change this to 1869 because I'm going to do something after. Okay, so I'm going to do 146 divided by 1869. Now this comes up as a decimal. The decimal, the decimal is actually okay by me. I'm not going to really get too upset if you don't change them into percentages. Other professors might get that upset. But it's a simple fix of, okay, when I do all of these, I really would like to change these into percentages. So I can go to where it clicks general and just click percentage. Now it's going to change this last one. Just hit delete. That's why I really typed in the 1869 number, because it would have messed with the percentage I just found. And then I just do the same exact thing for everything else. Okay. So I'm going to do 48 divided by 1869. And it's automatically going to put that in as a percentage. Okay. And then I'm just going to keep doing this for the rest of the table. I also do this for the marginal frequencies, but do know that if I add up across the row, it will be the same thing as if I take 222 and divide by 1869. Okay, so you can see that number is 11.88. If I were to delete that and add up the percentages in that row, I will still get 11.88. Okay, and that's just the way this works. Okay, because the joint distribution is based off of kind of moving up and then moving down. Okay. And then I'm just going to do the rest of the table. Now, this table is a little bit bigger than what I gave you both in the notes and in the homeworks and module assessments. It's because I wanted as many examples as possible for you to see. But now I'm regretting the size of the table, because I do have to kind of go through all of these and come up with them. All right, 649 divided by 1869. I'll do a sum across that row. And then I'm going to look to sum the column, because that will just be pretty much that. Now, if you haven't figured it out yet, if I go to the bottom right-hand corner, there's a little green box. It doesn't pop up right away. If I just drag and click, it will automatically add those sums as well. Okay, and then if I do the sum, there's that. And it should add up to 100%, because if I did this last box as the same way I did the rest of the table, I would divide 1869 divided by 1869, which is 100%. Okay, and that actually makes a lot of sense. So before I continue into the next phase, which is the conditional distribution, something that I want to talk about is, what do these joint distributions mean? Meaning, what are the types of questions that I could be possibly asked about a joint distribution that might seem confusing? So one of the questions I could ask is, I'm not going to throw out a conditional distribution or a given that I, will, when I do ask about the conditional distributions I'm going to do next. The question might pose as, what is the likelihood or the probability of a student taking 12 to 14 credits and receiving a 3.00 or greater? Notice, okay, there's a couple of things here. Let me just kind of clean this up. Okay, there's a couple of things here that I want you to notice. Okay, when I ask this question, there's no given. Okay, so that's kind of the first key that I'm going to be using a joint distribution. The second is the likelihood or probability. Okay, that's the second kind of indicator that I'm going to use the joint distribution. And then the third is the word and. The and kind of combines the two, okay, where now I know that I'm going to have to go inside the table. If I don't use the word and, like for example, let's say I'm going to ask the question, all right, and I'm getting a little bit ahead of myself, but I'll answer this question and then this one at the same time. What is the likelihood? Or let me just ask, what is the probability of a student taking 12 to 14 credits? So now what I've done is I've changed these two probabilities. In this one right here, I've included and to include two things. In this one, I've just said 12 to 14 credits, which means I'm only going to talk about one thing. So if I include the word and to talk about two things, I need to go to 12 to 14 and then 3.0 or greater. I see that that percentage is 13.59. So that means my percentage is going to be 13.59, and that's the likelihood of that situation occurring. Now, The probability of a student taking 12 to 14 credits means that there is no combination here, meaning I'm not looking at GPA at all. In fact, all I want to know is just what's the likelihood that someone's going to take 12 to 14 credits. So instead of going in the table where it is combined with the GPA, I'm just going to go to the bottom because that's the total number of students taking 12 to 14 credits divided by the ultimate total, which means my probability is going to be 31.30%. And that's a joint distribution. Okay, again, joint distribution just shows you the likelihood out of the total sample. Now, this is where it does get a little bit confusing. Okay, and I'm going to try my best to make sure that I do a good enough job explaining this. But what we're going to look to do next is called the conditional distribution. Okay, and the conditional distribution requires a condition. So the way that I always like to refer to it, am I saying given the row variable or the column variable? It's why I really like to do conditional probabilities with a two-way table. But when I taught it with the probability chapter, I had to do it without the two-way table because I had to make sure we understood that formula. Now that we've gotten past that, now I can get into the two-way table and talk about how the condition is identifying which variable we're focusing on. Okay, so for this first one, I'm going to focus on given GPA, meaning I am going to be given that the GPA, okay, is 1.99 or less, given 2 to 3, given 3 or greater. And then I'm going to find the probability of, all right, and I'll start to kind of go through this. But what I want to do is I just want to take the same table that I had before, except notice which side I am taking the givens from, okay? And I'm going to delete all the cells in here, okay? And I'm going to put in these row variables, okay? Notice that I included the right totals because if I know that I am looking at given 1.99 or less, I know I'm dividing by 222 because there's 222 students who received a GPA of 1.99 or less. What I'm looking at now is given that it's 1.99 or less, what's the probability that they got 11 or less credit hours? Okay, so what we're going to do is we're going to take that 146 and we're going to divide it by 222. And again, I want these as percentages. Okay, so I'm going to change these all to percentages. There we go. Okay, so what this would read as a question is given, actually, let me just type this out. Given the student has a 1.99 or less GPA, what is the probability that they took 11 or less credit hours? And that's the one I just did, okay? Because I know that they have a 1.99 GPA because I took it out of the 222, okay? What is the probability that they took 11 or less credit hours? It's that 65.77 because out of all the students who received a GPA of 2 or less, there were 146 that took 11 or less credit hours, which means I'm dividing by 146 divided by 222. Then I just do the same exact thing. I'm going to divide 48 by that 222, and that's going to give me that conditional probability. And then I do the last one, 28 divided by 222, and I get 12.61. What should always happen when you're making these tables is they should sum to 100% because I'm dividing by the row. So all of these should add up to that 100%. Okay. Now I'm going to do the same thing for the rest of the table. For the next row, I'm not going to divide by 222 anymore because my condition is now given 2 to 3 as a GPA. So I'm going to take 81 divided by 673, 283 divided by 673, and then 309 divided by 673. And then I'm going to finish with the last one. 71 divided by 974. Notice the switch. Okay, I switched because the row total is different now. Okay, 254 divided by 974. And then 649 divided by 974. And now what I've done is I've created the condition that given the GPA, these are the probabilities or the likelihoods of a student taking the certain number of credit hours. And I can quickly go through the table and identify, what is the likelihood that given a student got a 3.0 or greater, that they had 15 or more credit hours? Well, that's 66.63. Okay. And then I do the same exact thing. Okay. I'm going to do the same exact thing, except this time, instead of given GPA, what I want to know is given credit hours. I'm going to create that conditional distribution and notice which margin I got rid of. I got rid of the margin on the right-hand side because those totals aren't my conditional anymore. My condition is now based off of the bottom row, which represents the totals for each number of credit hours. And then I just do the same exact thing that I did before. So I'm going to take 146 divided by, instead of the 222, now I'm saying 298. And again, I want to change these all to percentages and watch what happens here, okay? Because I'm going to go through how this looks exactly the same as the last one. So now we are given 11 or less credit hours, and we're going to change the question to be, given that a student has 11 or less credit hours, what is the probability that they receive less than a 2.0 GPA? It's the same exact question as before. Okay, it's the same exact question. I just flip-flopped it. Instead of being given that the student has a 1.99 GPA, okay, I asked, and then what is the probability they took 11 or less credit hours? Now I'm saying, given that they took 11 or less credit hours, what's the probability of having a 2.00 GPA? This probability was right here, 65.77%, whereas this probability is 48.99%. And a lot of times students will ask the question, why? Why are those two numbers 17 percentage points off? Okay, and the reason why this is the case is 100% based, no pun intended, is 100% because of the given information that you have. So given is going to dictate what you're taking the number out of. So in this case, there were 222 students that got a 1.99 GPA or less. Whereas when I look at this one, there were 298 that took 11 or less credit hours. That larger group to take it out of is going to drop the percentage points because the overall group that you're dividing by is larger. Therefore, the conditional probability for that case is going to be smaller than if we were given a sample size or given a conditional distribution where the sample size was only 222. That's why the conditional probabilities, even just flip-flopping, which one we're talking about given, can have such a profound effect upon the overall percentage probabilities. Okay, so what I'm going to do is I'm just going to finish this table and kind of wrap up this video. Okay, so this was 48 divided by 585. Okay, and you can clearly see big difference again. Okay, and it's a big difference. And I don't know if we're actually going to get one where this table's larger. We will, but it'll be towards the bottom because that's where the numbers are bigger. So now we're going to do 81 divided by 298. I'm just going to keep going in this column. 71 divided by 298. And once again, just double check. Make sure that when you hover over those three that they add up to 100%. It's just kind of a way to double check to make sure you're doing it correctly. 283 divided by 585. And then there we go. We did get a number. We got two of them that were actually larger in that middle column. Okay. And you could start to see there's a big jump again from 7 to 23. And that's just kind of, little things that kind of occur within conditional probabilities. It can get tricky, but hopefully the explanation that I gave makes a little bit of sense. And there we go. All right. That table's all set. Now, that's the conditional distribution table based off of the marginal frequencies, which again, just represent the totals along the sides. And then, if we want to look at the cells individually versus the total, we don't use conditional probabilities because that's not using the total to make the percentage points. It's using something called the joint distribution. Okay. All right, guys. I'm gonna wrap up this video, get it uploaded. If you have any questions, please let me know. But gonna do the next video, which gets a little bit more in depth with the chi-square test. That is gonna kind of wrap up this module. Make sure to watch that video, okay? There's a lot of things that go on with the chi-square test that I need to make sure that you guys understand. And it can get very tricky because I don't know who has a yellow calculator, the TI-83 Plus. The TI-83 Plus does allow you to use a matrix to create the table, but the way that I'm going to do this in Excel does a really, really good job of coming up with the chi-square value, going through the test, and kind of understanding how to do the chi-square test using Excel. So please make sure to watch that video.